So, hello guys, you're welcome again to another video of mine. And today we are now on the checklist of the waves and oscillation. So we are going to be looking into 10 questions as usual. This is a very wide topic. So we are still going to do sound wave and light and other things. So now we are doing waves and oscillation, which include some part of our simple harmonic waves and as well as some parts of a simple harmonic motion. Like I do say, if you find anything interesting on our page, you can kindly subscribe and share the content with those that you think are in need of it. I will start with the first question. The first question before me here is the frequency of a wave having a wavelength of 20 centimeters and the velocity of 0.5 meters per second is dash. So velocity of wave or wave speed or wave velocity, the way you've called it in junior classes, is always equals to the frequency times lambda, which you can also write as frequency is 1 over period, and period is also 1 over frequency. You can also write it as lambda divided by capital letter T. So why I'm just writing like this is for other type of questions that might ask you to find the period. So this is a simple question, to be honest. This is a meter, this is a centimeter. So the wavelength we call lambda is equals to, that's 20 divided by 100, taking you through the process, which is 0.2 meter, which everybody knows. So the velocity was 0.5. The frequency, you don't know. The wavelength is 0.2. So on simplification, I told you I'll be leaving most of this stuff for you guys to be doing because I don't want to be wasting time. It should be 0.5 divided by 0.2. Sorry, this stuff is lagging. That is why I'm writing in a slow manner. So on simplification of this, my dear student, this is nothing but 2.5 Hz, which we call Hertz. So frequency is measured in Hertz for all revolutions per second. The second one, I'll be fast this morning. I want it to be like 20-minute video, possibly. So if we check the second one, we have which of the following with respect to the body, which of the following with respect to the body performing simple harmonic motion, that's an oscillation, are in phase. Now, for a simple harmonic motion, which is oscillation topic characteristics, you have to keep it in mind. The important thing, concept video available, is that acceleration is always proportional. It's always very proportional to the displacement. I think that's the definition itself of simple harmonic motion, which you might have studied in your junior classes. So if acceleration of wave is always equals to the what? To the displacement of the wave. So we say acceleration is always directed towards a fixed point. So whenever they are in phase, the displacement and what? The acceleration is always what? Equal. So acceleration forces produces acceleration. So there must be a force that is applied to a body to produce acceleration. And when it starts accelerating, it will be equals to the what? Displacement. So always keep that at the back of your mind. So the answer to this is nothing but B. Displacement is always proportional to acceleration. What brings acceleration is force. Are you getting it now? So be careful about when you pick answers to the new pattern of UTME questions. I hope you understand this because it's very important to understand. The next question will be on the next page. Fine. About this question, we have a wave is represented by the equation y is equals to 0.20 sine of, we are opening a bracket, 0.4 into bracket x minus, I cannot see this. I hope this is t. I just hope. I'm not sure if it is t, but I think it should be t. Here x and y in centimeter, the velocity of wave is dash. Now this is wave equation. Excuse my voice. From wave equation, you might have studied that you have the equation of wave, which is always written in different form. But I think the simplest form you can actually write wave equation is given in terms of y is equals to, this is lagging seriously. My writing stuff is lagging seriously, so I'm waiting for it to come up where I think I am back. Y is equals to a sine of 2 pi open bracket, ft minus x over lambda. This is more of the way most of your examiner like it. But the equation of wave is written as y equals to a sine, open bracket, of omega t minus kx when the wave is traveling in the positive direction. If it is traveling in the opposite direction of x-axis, it should be plus kx. Always keep that at the back of your mind. Because of new pattern series, I have done that on my video lessons, which is here to be posted because, I am taking all this topic critically with respect to the advanced level students. So I take my time to actually go and explain all this stuff in details so that it will be useful for you at any level in which you are doing physics. So solving this one now, we can just relate the equation. You can see they look similar. 0.20 sine, you have a 2 pi here is at 0.47, open bracket, x minus 60 t. So like I said, I am not the one that actually did this stuff, so there may be a typo error, but all the same, you go for symmetry. For example, you can say ft equals to 60t, fine. Yeah, you can say, then you have a ft equals to s over lambda. You are just relating by symmetry. So the one that has t here is ft. I'm not going to waste your time, guys. It's equals to 60t. So you can say f equals to 60 and still get cancelled out. So the one that has lambda, watch this, x over lambda, this is lambda, is equivalent to the one that has x there. S gets cancelled out. So what you have is a 1 over lambda is equals to 1. So lambda is equals to 1. So 1 centimeter, 50 or 60 at. The question asks you for wave velocity of the wave speed, which is always the frequency of the wave multiplied by the lambda. On simplification, frequency of the wave is 60. Lambda is 1. 60 times 1 is 60. I am solving in terms of centimeters per second. So because I didn't convert anything, so it will make my answer here towards choice B. I hope you understand this. So if you don't know these stuffs, just focus on what I am doing and just always keep at the back of your mind. You look for an equation of wave and look exactly that match the given equation. And after doing that, you are good to go to pick the answer. I hope you get that. So I just set them by symmetry. This is A. This is also A. So A is equals to 0.20. What do you call A from your oscillation of simple harmonic motion? A is called amplitude, the maximum displacement from the mean or the equilibrium position. So guys, it's not that hard. They are just simple. So this is just waves and oscillation. Sound wave is still there, which will be the topic for tomorrow, I guess, and other properties of wave. So guys, let's move to the next question. The next says, a simple harmonic oscillator has a period. Period is denoted by capital T, is 0.02 seconds. And an amplitude, question of oscillation. Amplitude is denoted by A. You can use capital A the way it is being denoted. I just decided to put small a. Calculate the speed at the center of oscillation. Answers are in terms of time. The speed of oscillator, the speed is always equals to, we are talking about simple harmonic oscillator. Speed is always equals to, what we call A sine. Let me just give you in terms of your stock. If you say speed equals to frequency times wavelength, let me just give you like that. Or you say A omega. If I want to write it the way you guys are used to writing it, like V equals to A omega. Or you say R omega, the way your teacher might have explained to you in your junior classes. So if I want to go with this, my A is the amplitude which was given, but my omega, I don't know. But from also simple harmonic oscillator, omega is always 2 pi f. That is why I said in Nigeria examination, when you cram formulas, I think you can solve a lot of questions. But when you are asked to prove formulas, that is where you have issues. So, but for your level, well, not that important, but it's always important to know how to prove for the sake of advanced level and for the sake of in case you forget the formula you have memorized. So, let's move on. Omega is now equals to F, I say what is inverse proportional to T. That is 2 pi over T. All these things I know majority of you have memorized. So if you go by what you have, that is 2 pi over the period is 0.02. So which you can divide by yourself. There is always calculator in front of you when you are solving now your, what's it called, your jam stuff. Because most of the UTME students will tell me that what they don't know where the calculator is. It's right in front of you. So 100 pi radian per second. That is the way we write that. That is just about the omega. So you are looking for the speed, which is called linear speed. Amplitude 0.25 multiplied by 100 pi. The answer is in term of that. As you can see, this it goes without saying. This is the correct answer to that. So just multiply the answer by 0.25. 0.25 is what I mean by 0.25. So you have 25 pi, and that is the right answer, meters per second. So please, it's already given here that the speed is in meters per second. So I hope you get that. And if you don't get it, you are always free to send me the area you don't get by direct contact on a WhatsApp available on the channel. So the next is this. Which of the following phenomena does not apply to longitudinal waves? Now, you have studied about properties of wave, which are reflection, refraction, diffraction, and interference, which is common to all types of waves. But a particular property we call polarization of waves in your junior class, the polarization is only common to transverse wave. In fact, we say longitudinal wave cannot be plane polarized. So I think this is a famous traditional question, good questions that most of you might have come across in your junior classes. So the answer to that is nothing but this. All these are properties of waves. As you know, interference can also be called what? Superposition, though there is distinction between the two, which you can watch on concept video. When two or more waves overlapped, it is called interference. So the overall waveform that is formed when two or more waves overlapped can be constructive or destructive, which is called superposition. Well, that is just not for today, because I am only taking you through some other way you can see questions to avoid issues. Now, on to the next question. Which of the following waves are both mechanical and transverse? Now, we have two types of wave, which you might have studied also in your junior classes. About the two types of wave, we have what we call mechanical wave, those that require material medium, and you have the one they call electromagnetic wave. I'm not just solving questions, like I said. The essence of this is to take you to a checklist, quick explanation on how to get answer. So we now define mechanical wave into two forms of other wave, which you now call the transverse wave and the longitudinal wave. So which is basically what I believe you have studied in your junior classes. Material medium, they do not require material medium. So in fact, a topic on its own is electromagnetic wave, which we are still going to do questions on them separately. So which is why you need to stay here. So by what I want to explain now, they are what example of them are you have the sound wave, you have the water wave, you have the alpha ray, you have the beta ray, to mention but few. So now when you now divide them into transverse, that is based on their mode of propagation, based on their direction of traveling. Transverse are those that travel perpendicular to the direction of traveling. A very good example is water. Water is transverse. Whereas, based on the direction of being parallel to the medium, you define longitudinal wave. An example of that is sand. So that is what differentiates them. Both of them are mechanical, but when it comes to their mode of traveling, we can also differentiate in terms of transverse and longitudinal. So I hope you understand. So to answer this question, both mechanical and transverse, mechanical are this. Which of them is now transverse? It is water waves, and that is the right answer. I hope you understand this. So we move to the next one, which is question 7. Fine. About 7, we have the new pattern. The wave described by y is equal to 0.25 sine 10 pi x minus 2 pi t. Where x and y are in meters and t is in seconds. Is traveling along the dash negative direction with frequency 1 at. Okay, fine. The first thing is what? Because this equation is minus, I said that the other time, it is traveling towards a positive x answer. So all this negative direction is what? Gone. You can see UTME, you can quickly pick answers. So you have to answer, so you just have to solve. Equation of wave with respect to the way it is being written is a sine 2 pi is not factorized, so you write it as 2 pi ft minus 2 pi x divided by lambda. So this is the equation of wave. This is the one that was given, 0.25 sine, open bracket, you have 10 pi x minus 2 pi t. By symmetry, you can say the one that has x, the one that has t is this. You can say 2 pi ft, I'm not supposed to be doing this, is equals to 2 pi t. On simplification, my dear students, 2 pi gets cancelled out, t also gets cancelled out. So what do you have? F is equals to 1. So the frequency is 1. Frequency is 1. So I think this is the answer. I may not solve the wavelength to save time, but if I want to solve the wavelength, I set this equal. Look at this, guys. 2 pi x by lambda is equals to 10 pi x. On simplification, pi x gets cancelled out. 2 here 1, 2 here 5. So you can say 2 also here 1, here 5. If you don't know how to cut like that, please cross multiply. So 1 over pi is equals to 5. Cross multiply. Pi will now be equals to 1 over 5. What is 1 over 5? 0.2 meter. So you can see that distance I have picked is very common. So please note, negative indicates positive x-axis, positive indicates the wave is traveling in the other part. So always keep that at the back of your mind. So, guys, the next question. Maybe I should leave this question for you guys to try. When a sound wave of frequency 300 Hz passes through a medium, the maximum displacement of the particle is 0.1 meter. The maximum velocity of the wave is dash. Maximum displacement from the mean position is always called amplitude. So amplitude again is given. I think we have solved these questions before. Now the velocity of wave, because now it is not an oscillation of simple harmonic wave, of simple harmonic motion. It is now simple harmonic wave, which we call waves generally from your junior classes. So V equals to F lambda. Remember that you can get lambda is 0.1. The frequency is here. What's the frequency? 9. Very good. Now, this is another thing, because some of you can say the maximum displacement from the particle of the medium is 0.1 centimeter. So that is just the issue here, because we need to know that, like I said, velocity of wave. A wave oscillation is called simple harmonic wave. Let me take you through that very quickly. You let me brush. And the other type of oscillation is simple harmonic motion. You have studied in your junior classes. Now, for a plane progressive wave, they exhibit the same property. Do you understand? So that is why we use the same equation. They call that y is equals to a sine. This is a simple question. I just want to show you how I come about it. Y equals to a sine of omega t minus kx is your equation of a simple harmonic motion. It's also the equation we have used to derive different pattern of simple harmonic wave too. So always keep that in mind, that what they exhibit, plane progressive wave also exhibits what a kind of a simple harmonic wave in it. So if I have written the speed of simple harmonic wave as what you call r omega or a omega, which we have done the other time, always keep it in mind that omega is your angular velocity or whatever you call it, which is always on 2 pi f. So my point here is that directly, if I want to take the maximum displacement of the body as it is moving, this is not from mean position. Keep it in mind. It's a maximum displacement. That is the distance covered by the wave. So please be careful about this type of question. I know why I'm doing this, because I know a lot of students are going to fail this question because they only have basic knowledge. And sometimes basic knowledge might not be good for you to solve what your question. So omega is equals to 2 pi f. Right? Now you can see I'm using the simple harmonic wave equation. This is 2 pi multiplied by, what is the frequency? 300. From simplification, this is 600 pi. I know you know this, we've done it before. Fine. So now you can now say the speed, because I said they exhibit the same thing, is now equals to a is 0.1. The answer is in centimeter. I don't need to convert. I multiply that one by my 600. So that one is going to give me nothing but 60 centimeter pi per second. So 60 pi centimeter 60 pi centimeter per second. So please, pi is in my answer, even though this there should be x also here. So this is the answer to that and not this, because there is no pi here. So that's that. You can see the way they exhibit the same thing. That is why we treated them on the same topic. So I think that's all. Or do we still have one phase more? Wow, we have a phase more. When the sound goes from one medium to another, the quantity that remains unchanged is that. You have talked about that the speed of wave is proportional towards the wavelength. And when we introduce the constant, we have f lambda. So where f is what? The constant. Always keep that in mind. It's a simple first off. Under the refraction of light, when we get to the last part of light, we also let you know that, we talk about property of wave also, which is refraction. When wave travel, when wave change course or changes direction, they don't what? One thing they don't change is what? Their frequency. As it comes here, when it reaches a boundary, it will change what? Course. So it has been refracted, speed and wavelength changes, but frequency remains the same. So this is the answer to that. And that is that about that. So the last question for today, this is the answer, guys. Frequency is constant. This is also simple. Of the following, the equation of a plane progressive wave. A plane progressive wave exhibits simple harmonic wave, which is more or less like what your simple harmonic motion in your oscillation. So the topic is simple harmonic motion, oscillation, and wave. And the last question is what I've talked about the other time. Y equals to a sine of omega t. I've written it in the last one minus kx, which is what? The same thing as the simple one. So the amplitude here is taken as a radius. So the correct answer here is nothing but what? Choice B. So always keep that in at the back of your mind. You can see the way I have solved all these questions accurately. You can always do better. There's nothing limiting you from not knowing physics, because physics is interesting, lovely, and when you know it, you have what? High confidence to solve any type of question. So guys, we'll stop here for today. I'm going to see you guys soon tomorrow by the grace of God. Don't forget to share our content, watch, you can download, and let your friend know about it, because if you download them, you can watch them over and over again. So thank you for your support, you guys, for watching every day. And for those that are subscribing, we appreciate you. See you soon. Do have a wonderful day ahead. Bye for now.